Hello, how are you, sir? My name is Taif Ayad Khaleel. Today we'll present the solve for travel salesman problem with the K nearest neighbor algorithm. In this presentation, we will talk about introduction, problem statement, K nearest neighbor algorithm, survey study result, and conclusion and future work. In the introduction, the travel salesman problem, the root of this travel salesperson problem are unknown. Manual from the travel salespeople published in 1832 and now acknowledge the problem and give the simple thread across Germany and Switzerland. The KNN or K nearest neighbor algorithm is a non-biometric classification technique invented in 1951 by Evan Fix and Joseph Hodet, and later expanded by Thomas Cover. The travel salesman problem. The travel salesman problem, as we know, TSP, is an algorithmic problem in which the goal is to discover the shortest path between the collection of points and place them must be visit the city that the salesman could visit are represented by the point in the problem, and finally we will back to the first city. KN or K nearest neighbor algorithm. K nearest neighbor algorithm KNN is a non-biometric method proposed by Thomas Cover, used for classification and operation. In both cases, the input consists of K closest trainings example in the future space. The output depend on where the KNN is used for classification or regression. KNN implementation on TSP. This is a simple example of the problem as we show on the right. From point A, the shortest path we can take from point A is B because it's equal to 4. Uh, that when between A and B is 16 and between A and G is 9. So the shortest path is B because it's equal to 4. From B it will be the shortest path is to G because the shortest path to C is 20. The path to C is 20. So the shortest travel between is B and G, and so on. The the result will be as following in the left side: A, B, G, F, D, E, H, C, and A in the left, so that we come back from the last point, it's C, to the start point, it's A. Here will be see the table that present the value in the figure on the right. If we take uh, the column A, the smallest value in that column is 4 with B. So this, from A we will go to B, and from B we will remove the value of A because we take it before. From B, the the remaining shortest path is G, is equal to 8, and so on. In that method, if we start from A, the result will be 71. But if we start them from another point, that will be the we may have different resolution, different result, and different it will maybe best or worse. So if we start from B, the cost will be 68. 68. So that resolution will be better than when we start from A. can sorry conclusion. If we apply minimum spanning tree method on the previous exam, that will be the lower point is 64 and the upper point is 71. So we can the minimum value we can solve this the previous exam is will be 64, and if we solve it more than 71, it will be not efficient way. So the upper value we can solve it is 71. Everything past 71, it will be not efficient and will cost more from us. So when we have from point B and G, the value will be 68 in the in between value that minimum spanning tree have given us. So it's the efficient way to solve the problem, and KNN is a good way to solve the problem, but not the most efficient way to solve. If we try another algorithm, we may have the value of the result value of 64, and so on. It is still a good way to solve the problem, but it is not the efficient way. In future work, we can use another language, and another language than MATLAB. We can use Python, Java, anything. We can discussion the city and the travel between it and between the city and the coast, the length between the city and the coast. As example, if you start from Ankara to Istanbul, it will take about 110 and 8 hours, and so on. If we take 5 or 6 cities or whole the country, we will from any city we will have the destination and the value to another city, and so on. We will point every city to another, and then start it beside the random value. It will give us the solution about that. And now I finish the presentation. I will present the MATLAB code that I use it to solve this problem. In this MATLAB code I use it. Here we will randomly have five points in the map. And city it will represent the number of city, as we here will have 5 cities. We can have more, have less, but it cannot have less than 2. Here we define the variable, and when we have the counter here from I equal to 1 to the number of cities. The start city will represent the 1 here, and but we have not traveled yet, so but يساوي equal to city start city. Destination travel, it will be equal to 0. We are in the start city yet. Destination we here have the new destination, and يساوي destination will equal to each other. Now we are in the next city, current city. It will equal to start city, so that we have here the city B as example. If we have the first city equal to A as example, the second city will be equal to B, and when the start city here will be B, and we will repeat the solution until the loop or the counter is finished. Here will I to number of city minus 1. Here will counter of the main destination, next city and main destination new, current city, and so on. Here will be have path will so the last path will be back to the first city. Here we will have the figure from the main city 1, city 2, and so on. Here we have the representative of nearest neighbor and shortest path between the two cities, or so on. Now I am running the the program. Here we will see the point that randomly given by the system from the round 50 run, and here we'll see the travel length that we travel between the 5 cities. We can have more points here. As example, if we have 50, sorry, if we have 50 points and have another run, here we'll see that more than 5, it's 50 points, and all of them have linked together, and this is the destination length we have traveled. Or you can say the cost we will have to travel between this line. We can also have a very large point, as example 100. This will be the travel salesman, and by using K with 100 points, and that's the whole destination or cost we have to solve 100 points. So thank you for listening to me, and goodbye. Thank you, David.